In today's video, cable spaghetti and some expansion cards. Hello everyone and welcome to a new video. This is part 2 about the Intel N100 server upgrade, featuring our lovely Asus Prime N100I-D D4 motherboard. We've got some care packages in today. We have a SATA controller card and we have the elusive 2.5 gigabit network controller that we can put into the Wi-Fi slot, at least in theory. So what we're going to do today is actually install these parts, test them out, see if they work, and if they can serve their purpose. I think they will, but we'll find out. What we can see here is just a basic SATA controller card. It is very, very black. And yep. Probably some kind of J-Micron or something controller on there. I don't really care too much. This will be running just 2 hard drives. Nothing spectacular there. And it will just sit right here in this slot over there. The most interesting thing is actually this one. This is a 2.5 gig card. It has a Realtek 2.5 gigabit controller on it. It's the same Realtek controller that I'm running in the other server. The one that this board will be put in. I also used it in my test server for a good while, and it's now in my NAS because the network card in that thing, kicked the bucket. So, yeah, I'm actually quite happy with those Realtek controllers. They've been very stable so far. As you can see, we have a regular RJ45 jack here, with a little extension cable that goes to a little board here. It looks very much like a standard issue Wi-Fi card for a laptop. It will sit right there on the board. And we should be able to get 2.5 gig speeds out of this one. This board uses PCI Express 3.0 for chipset control devices. So that is the Wi-Fi slot and the PCI Express X1 slot here. In theory, it should be capable of 1 gigabyte per second. So even a 10 gig NIC should sort of exist and work, I think, for this. We haven't found any 10 gigabit NICs that will work in a Wi-Fi slot like this. Maybe that's something for the future when the entire system is SSD only and we need some extra bandwidth. But for the time being, my infrastructure is 2.5 gig as of about a year now, and I intend to stick with that for the next couple of years. So what we're going to do, we're going to put this in. There's only one way to put it in. And it's going to be a tight squeeze because there is a header there just below the card. We'll have to get a tad creative, but yep, it appears to fit. It seems to be able to be held on just by friction. I'm not terribly happy about that fact. Of course, they don't give us a magnetic screwdriver because why would they? It's premium grade Chinesium, after all. In that case, we'll use iFixit because their stuff is sort of reliable. Alright. I hate M.2 screws with a passion. Yep, it's going down. Alright. This cable is actually quite long. I think this will reach in the server case far enough for it to be mounted to a bracket, something like an old graphics card bracket or something. That's what I'm thinking of. Whoops. Alright, let's get the Ethernet in here because I've already patched that cable into a 2.5 gig port so we can test the full speed in just a bit. I'll also put in the SATA controller card. Get some SATA SSDs. These are Samsung 2TB PM863A. These are X data center drives. I don't know the health of these particular two. I just sold a couple of these off. And I'm keeping a couple for my own stash and experimentation purposes. So that's what they're for. Let's hook up the power supply side first before we put them anywhere close to the board. There we go, that's one of them. And then the other can go in here. Yep. Fits like a glove. Of course it does. This is gonna be gnarly looking. Should have turned this one around, shouldn't I? Oh well. Yep, I'm just being stupid. Alright. Nothing new there. There we go. So we now have our 2.5 gig Ethernet, we have our SATA controller, so we should now be able to turn the system back on and have everything working. And let's see here. Ooh, it has LEDs. It doesn't have RGB, but it has B. And now it has nothing. Excellent. Alright, okay. So everything is working on that part. Let's see what's going on there. Alright. Let's log in there. Got everything working okay there. There we go. This is server 2025. This is an early build. What I want to see is device manager. We should see a 2.5 gig controller. And we do. It's called Realtek Gaming 2.5 GBE family controller. It's picked up natively by server 2025. The drivers from 2022. I have a flash drive with a newer driver, but if this one works, I'm probably not going to touch it just yet. We'll do that later to see if it gives us any performance benefits. Let's see. Do an IP config. We can see we have 2.160. Okay. Sounds good to me. Let's see if we also have a SATA controller. We have a PCI device and an unknown device. Actually, I'm not entirely sure if they were there before. I think they were, but who knows? Otherwise, we'll just have to install a driver for those. We have device manager there. Go to disk management to see what's going on there. We don't appear to have two drives visible, but we have one. So one of the drives is not detected. Okay, well, that's something. I'll troubleshoot that in a little bit. And we'll pick this up again at the computer with a screen capture via RDP so we can have some fun with this and go from there. Alright, so we're at the desktop now. Let's go into the server here. There we go. It turns out that one of the disks wasn't plugged in, so we should be able to have both of them up in disk management, which we'll pull up here. And we do have two 2TB SSDs right there. Okay, let's actually make some use of them and go for a disk part. List disk, select disk 0, clean it, and select disk 1 as well, clean that. So we don't have any partitions. Now we can initialize them both at the same time with GPT. And what we're gonna do is we're gonna do a software RAID. We're gonna do a RAID 1 for mirror. So we're gonna choose new mirrored volume. Make both of them members of the mirror. Assign the D, very important. obviously. Usually I would put virtual machine storage on there, so that would be ReFS, that would be the best. But this is just for testing purposes. We're going to go with NTFS for slightly better performance overall. That's what, at least in my testing. But, you know, there's not much of a difference there. ReFS is mostly for better performance on virtual machine storage and for deduplication support. NTFS does not have that. The downside of ReFS is that you cannot use encryption on it as well, or compression for that matter. So we're gonna call these volume the D, perform a quick format, and they will turn into a mirrored set of drives. Any data that's copied to drive 1 will automatically be mirrored to drive 2 there. We have drive here, the D, with 1.74 terabytes available space. And we can create a folder right there. We can call it test, so we have a folder. What we're going to do next is create a share on this particular drive so you can do some performance testing. Let's actually just point it to that folder we just created. Make that a share. I don't want any caching because that is actually going to ruin the results. We want uncached. This is the NVMe drive. I also created a share on that. I'm actually going to make sure that the settings are the same. There we go. We have 2 shares we can abuse on our system. And the next thing I want to try is get Crystal Disk Mark so we can do some performance testing. Yep, we want some dark mode right there. Absolutely despise Microsoft Edge in this way where it's first run. Let's go to Google and go to Crystal Mark. There we go, Crystal Do World. Crystal Disk Mark. We don't want Crystal Disk Info, that's just going to tell us the smart values of these drives. I'm not terribly fussed about those. Most of these 2 terabyte SSDs are at about 86 to 90% health. They're ready for 2.7 petabytes and they've written about 500 terabytes, so they're still well within spec, but yeah. Is that going to be a factor in our performance metrics here today? Okay. So let's do a 1 gigabyte test. First of all, we're going to do a run on the internal NVMe drive just to get an overall run and look at the performance that we get there. That's directly connected to the PCI Express bus, of course, with 2 lanes in case of this motherboard. So it will max out at 2 gigabytes, but this SSD won't do 2 gigs. Alright, that's the read test done. We'll continue with the write test. I'm just going to let it run, and then we're going to start and do the same results once again for the internal RAID set. And then we'll get back to compare the results. Okay, that's the results done for the NVMe drive. We'll open up another window and do the same test once again, same settings for the D drive. And before we run these tests, first of all, I'd just like to get out of the way that the reason I'm doing these tests is just to see what the max speed is. We can see that the 2x PCI Express 3.0 limitation that this board has for the NVMe drive is not hampering it at all. Seems to run its max speed just fine. It will actually get to that 2 gigabytes per second, I think, if you put in a fast enough drive. And the SATA controller is on a X1, so it should only max out at 1 gigabyte per second in the best situation. And with a RAID 1, we should be able to approach that 1 gigabyte per second. Not in writes, but we should approach it in reads. So let's run it and compare the results after this. Alright, and the Crystal Disk Mark is done. We can now see that our NVMe drive and the disks connected to the SATA controller are doing some decent speeds. The reason I wanted to see what this array could do is because the 2.5 gigabit controller that we've just installed is capable of 2.5 gigabit divided by 8 is roughly 300 megabytes per second. So in a sequential write or read from a share on this server to a client and vice versa, we should be able to approach 300 megabytes per second. And we're not going to be bottlenecked by the internal drives. Should you use internal hard drives, you're going to need a couple more drives in order to actually get close to these speeds. But with SSDs, even just reasonably cheap SATA ones, you should be able to approach those speeds no problem. And we can see that here. So for context, our drives are fast enough. So the only thing we need to do is map the shares that we've created on this server and do a couple of file transfers and see what's going on. I'll have to perform these from a system that has 2.5 gig Ethernet. So I'll have to get that set up and we'll go from there. Alright, I forgot that my desktop was downgraded to 1 gigabyte or gigabit per second because of issues. So yeah, I've just put in a 2.5 gig Ethernet adapter, so we should be able to go full speed. Let's verify on Ethernet here. Yep, we're connected at 2.5 gig speeds, so no bottleneck on the network either. Alright, let's connect these drives through the network. We'll map a drive to the 2.160. We have one called ISO. Administrator and a password. There we go. That's on the NVMe drive. And we have another share. It's called test. That is on the internal SATA SSDs. Okay. Now we could run another Crystal Disk Mark again on the network shares, but I'm just going to copy some files over because that is a better test in my honest opinion. Not that you should accept my opinion whatsoever, but you know. Okay. We have ISO here. And we have test over here. Okay. Slightly smaller window than I'm used to, but that's no biggie. Okay. Let's see if we have any big files in our downloads folder. Yep, we have a 7-zip file of 2 gigabytes in size. We're going to be using that. First, we'll copy it to the... Let's see here. I bloody hate Windows 11 sometimes. To the ISO share first. We're not allowed to copy files. Well then. Let's have a look. Not even the administrator has permissions on the share. Oh, that's something. It is shared. Permissions. Right. Good old-fashioned Windows file sharing. Okay. Got the D fixed. Now we need to fix ISO share. There's always more than one way to get to the sharing settings. Typical Windows, right? Accept that, apply that, close that, and try again. Well, that looks like gigabit to me. Huh. It is entirely possible that the cable that's in that system is not actually capable of running at 2.5 gig. Never considered that to be a possibility, but it's entirely possible. Yep, got the same performance on both of them. Okay. Let's verify. Go to the network settings on the server here, do some troubleshooting. Ethernet. Network connected. Yep, we're at 1 gig, unfortunately. Okay. Well, at least we have some information there. I'm gonna fix that real quick, and I'll be back in a jiffy. Alright, one split patch cable later, and we have 2.5 gig on the server now. Alright. You can't make this stuff up, can you? Right. Okay, let's try this one again. Again, 2 GB file. First we'll put it on ISO, on the NVMe. There we go, that's what I'm expecting. 280 megabytes per second. Yeah, subtracted some overhead from the achievable 300 something. That's not bad. Let's try it again on the internal SATA drives. Yep, about the same speed, 280 megabytes. Seems to saturate just fine. Okay. Yep, I'm worried this might not be a safe file. I don't really care too much. We're going to delete the original file here and do a retest. Yep, that's perfectly acceptable. 250 megabytes. That file is synced immediately to my NAS again, so it might not be a perfect test. I'll put this file on the internal drive instead. W drive is not available. Yeah, it is. It's right here. Okay, I'll put it in here then. That's working fine as well. Yeah, this is just about what you can expect with the 2.5 gig Ethernet. It's definitely a good bit faster than just regular gigabit. You're approaching 250 to 300 megabytes per second on read and write actions. And it would appear that the Intel N100 is totally capable of doing that. Even with a SATA controller with just one lane attached to it, that seems to work okay too. Alright, that leaves me quite satisfied with its performance so far. I would love to see what it can do with 10 gigabit Ethernet, and we might actually visit that a little bit soon, but, well, actually, come to think of it, there's no real way for me to test that right now. I only have 1 gigabit or 10 gigabit controller that's coming in later this week, and I'll be putting that in the NAS to get that back up to 10 gig. Maybe in the future we'll revisit this system with a 10 gig upgrade and see what it can do there, but at least we know for sure 2.5 gig is completely fine. Even able to saturate a SATA controller with 2 drives attached to it that are SATA SSDs. So that's perfectly fine for me. That's absolutely ample performance for what I'm going to do with this system, and running Hyper-V and all that stuff. Okay, I think that is it for this video. This was part 2, where we installed a 2.5 gigabit Ethernet controller in the Wi-Fi slot, as well as a SATA 4-port controller with 2 SATA SSDs attached to it. And we did some nice performance tests, verified that this solution is actually viable. I'll put links to these items in the description so you can have a look for yourself. I cannot guarantee that these items will stay available at AliExpress or anywhere else, but they're just to get an idea of what they are and what you can expect from them. And maybe you can buy some for yourself. I'm not affiliated with anyone on this channel. Everything is out of my own pocket. It's my own time, it's my own money. So just to be transparent about that. And yeah, hope you enjoyed this follow-up video. I thank you all for watching, and I'll see you guys in the next video.